We will delve now into the topic of attention that we mentioned in previous lecture. What we will see in the lecture now is attention works in recurrent neural network, what is self-attention, and what is multi-head attention. Attention enables the encoder to produce a hidden state for each step, allowing the decoder to access each of them. However, using all the states at the same time would overwhelm the decoder. Attention provides a mechanism to prioritize which state to use. Attention allows the decoder to assign weights, and this is what attention is, for each encoding state during each of the decoding steps. This is an example of how attention works in RNNs. We can see that the weight for the state 2 and 3, which correspond to the word are and great into the sentence transformers are great, are bigger when they translate into the sequence in German. To explain this better, let's focus on the fact that attention-based model learn meaningful association between words. In this visualization of attention weights, each weight that corresponds to a pixel illustrates the ability of the decoder to align two similar words. In particular, between the English sentence, the agreement on the European Economic Area was signed in August 1992, we see that the most important attentions are on the words European Economic Area and Zone Économique Européenne in French. This explains how attention mechanisms are able to associate similar words in similar contexts. Nevertheless, while attention improved the quality of sequence processing, including translation, the computation in recursive neural network was still sequential and cannot be parallelized for the sequence in input. Self-attention improved this aspect. Transformers introduced self-attention that eliminates the need of sequential processing. Self-attention makes attention to operate on both the encoder and the decoder, and by leveraging this architecture, the training becomes significantly faster compared to recurrent models, and this aspect paved the way for all the recent advancement in transformers. In this example, we can see how the self-attention mechanism is different from the attention mechanism in recurrent neural networks. Which are the benefits of self-attention? Attention is credited to play a significant role in helping LLMs to learn and to recognize internal words and human identifiable rules. For example, in BERT, specific attention calculations are aligned with the linguistic concept that we understand as human, concepts like the syntax or the grammatical rules. BERT demonstrates impressive accuracy in identifying objects like verbs, nouns, and prepositions. Nevertheless, one further benefit of self-attention is that experiments revealed that models using self-attention could understand games following the rule by training the model on historical data, only by data regarding the game. This highlights the ability of transformer model and LLMs to catch complex rules and patterns. There are also some drawbacks. And for example, the most important is that one single layer of attention tends to focus predominantly on one aspect of the language. In this aspect, having multiple sets of attention layers proved to be advantageous. Multi-head attention incorporates multiple self-attention layers. Incorporating multiple attention layers enables the model to simultaneously focus on various aspects. For example, one head can focus on understanding the interaction between the subject and the verb, and other layers can focus, for example, on identifying verbs, adjectives, and nouns. This is an example how self-attention operates at the end, where on the top we see in the sentence, time flies like an arrow, that flies in the first sentence is associated with arrow in order to understand that is a movement. While in the sentence, fruit flies like a banana, flies, in this case, is associated with banana, understanding that we're talking about insects that are on fruit. This relationship, and this is the amazing part of these models, are learned directly from the data without any manual intervention. So what we'll learn in this lecture? We'll learn that attention provides a mechanism to prioritize which states to use in the encoder-decoder architecture. Self-attention enables the possibility to make computation parallel and to operate on both the encoder and the decoder. Having multiple set of self-attention layers, technique known as multi-head attention, improves the understanding of text.